All right, welcome to The Explainer. Today, we're diving into a technology that sounds like something straight out of science fiction, but it is getting more and more real every single day. We're talking about metamaterials. And these aren't just new materials, they're a totally new way of thinking about what matter can actually do.
So let's just cut right to the chase, shall we? It's the question we all have. We've seen it in the movies, we've read it in the books for years. But could we actually have a true invisibility cloak for real?
Okay, so take a look at this. And no, this isn't some CGI trick. In late 2023, a scientist named Chu Junhao stood on a stage, rotated a panel, and made his legs just disappear right in front of a live audience. Suddenly, that line between science and, well, magic, it's getting really, really blurry. So here's how we're going to break this all down. First, we'll pull back the curtain on this magic. Then we'll get into the actual physics of what metamaterials are. After that, we'll look at what they can do beyond just invisibility, talk about the challenges ahead, and finally, get a glimpse of the future this tech is building.
So how in the world did he do that?
Well, it's not actual magic, but it is some brilliant, brilliant optical science. And it turns out there are a couple of different ways engineers are trying to crack this problem.
So that trick we just saw on stage, that uses something clever called a lenticular array. It's basically a sheet of tiny, tiny lenses that bend the light from the background towards you, so it just skips right over whatever is behind it. It's really impressive, but it's not quite true invisibility. But the real holy grail, the thing scientists are truly chasing, that's creating a material that can make light waves literally flow around an object so there's no reflection, no shadow, nothing. And to do that, you need metamaterials.
Which brings us right to the heart of it. Let's talk about the core technology that makes all of these incredible things possible. Let's enter the world of metamaterials.
So what is a metamaterial, really? Well, it's a synthetic material. And its wild abilities don't come from what it's made of, its chemistry. They come from its structure. Think about it like this. The power of steel comes from its ingredients, iron and carbon. The power of a metamaterial comes from its architecture, these tiny, repeating, man-made patterns. We're basically engineering how it interacts with the world on a fundamental level.
Now, one of their most famous, I guess you could call them superpowers, is a property that just shouldn't exist in nature. Negative refraction. In every natural material we know of, when light passes through it, it bends in a very predictable way, right? Metamaterials, though, can be built to bend light in completely the wrong direction. This totally unnatural ability is the key that unlocks so many of these futuristic ideas. And believe me, this didn't happen overnight. The idea was first dreamed up way back in the 1960s. It wasn't until 1999 that we got a real blueprint for how to build them. And then in the early 2000s, scientists finally proved it could be done, at least with microwaves. And today, the research has just exploded to cover all kinds of waves. Look, invisibility is an amazing hook. It's what gets everyone's attention. But honestly, it's just the tip of the iceberg. The ability to control waves, whether it's light, sound, heat, or even physical motion, is about to set off a revolution in dozens of industries. So let's just push this idea a little further. Bending light is cool, sure. But what if you could take that same principle and apply it to sound waves to make things perfectly silent? Or even something as powerful as the destructive force of an earthquake to protect a whole city? See, this is the real potential of metamaterials. We're talking about everything from next-level stealth for the military, to earthquake-proof buildings, to paper-thin lenses for VR, more powerful medical scanners, super-efficient antennas, and even better solar panels. It's a game-changer across the board. Let's just take that earthquake shield idea for a second. It sounds like pure sci-fi, right? But researchers are actually designing what they call seismic metamaterials. The idea is you'd bury these huge structures in a ring around a city. When an earthquake's seismic waves hit them, the energy would just be channeled around the city, just like water flowing around a big rock in a stream. It's an incredible concept. And this revolution is happening on a much smaller scale, too. A thick, curved glass lens can now be replaced by an almost flat, ultra-thin metal lens. Imagine VR headsets and cameras that are radically thinner and lighter than what we have now. Or in medicine, these materials could lead to ultrasound machines that give us images with a clarity we've never seen before.
And communications? That's another huge area that's about to be totally disrupted. You know, with traditional antennas, there's always been a basic rule. If you want better performance, you need a bigger antenna. Well, metamaterial antennas just break that rule. They can be smaller, way more sensitive, and more efficient. You could even build them right into the skin of a plane or a car.
Okay, so as incredibly exciting as all of this sounds, we need to pump the brakes just a little. We're not living in this metamaterial world just yet. There are some pretty major technical and even ethical hurdles we have to get over first. First up, you've got the raw technical challenges. Just designing these things is insanely complex and takes massive supercomputers. Then you have to actually make them. And manufacturing these intricate little structures at scale is a total nightmare. And finally, you have to turn those lab experiments into real products that are tough, light, and cheap enough for everyone to use. It's a huge, huge engineering lift. And then, of course, there's the ethical side of things. As one source puts it really bluntly, the power of invisibility brings up some serious questions. It could be used for hiding from the police. Figuring out how to use this responsibly is absolutely crucial. This isn't just about science. It's a question for all of us. But even with all those challenges, the momentum here is just undeniable. It's really not a question of if anymore, it's a question of when. And the amount of money and strategic interest being poured into this is enormous. And the numbers, they really tell the story. I mean, just look at China. The market there is projected to explode to over $4 billion by 2029. And around the world, some folks think the market could be worth over $50 billion by 2030. This is very, very serious business. And yeah, the race is absolutely on. The U.S. Department of Defense calls this a top disruptive technology. You've got the big military players like Boeing and Lockheed Martin who are all in, tech giants like Apple and Intel are investing, and China has made it a national priority. Basically, everyone who's anyone in tech and defense wants a piece of this future. And that brings us full circle, right back to where we started. This quote is from that scientist we saw earlier, Chu Junhao. He's convinced that what started as pure fantasy will one day just be a normal item you find in your closet. Because ultimately, this is about so much more than just cool new gadgets. Metamaterials give us a kind of control over the physical world we've never had before. For the first time in history, we're no longer just limited by the materials we can dig out of the ground. We're now empowered by the structures we can literally imagine and then build. And that leaves all of us with a pretty profound question to think about. When we can engineer reality itself, what kind of world will we choose to build?